I know that we took a little bit of notes a couple days ago, and I was calling that Unit 1.1, but we're going to kind of restart with Unit 1.1, okay? So we're kind of doing it again. So Unit 1.1, and this is all about rational numbers.
Didn't we do this that one day?
I know, we started it, but we're going to finish it, so I'm kind of like redoing it because I made it better this time. So Unit 1.1 is all about rational numbers. Is anyone having a hard time seeing that? I probably need to turn off one of the lights so you can see a little bit better.
Yeah, that's better.
It should be getting, there we go, now you can see it a little bit better. Okay, so first thing I want to do is write down the technical definition of a rational number. Okay, so a rational number, or rational numbers, and this is a definition, so I'm just going to write equals. Rational numbers are numbers that can be written, numbers that can be written as a comparison of two integers, and I'm going to give you time to catch up if you're not quite as fast at writing as I am. Numbers that can be written as a comparison of two integers expressed as a fraction. Okay, numbers that can be written, oh, you can't quite see that. Numbers that can be written as a comparison of two integers expressed as a fraction. Can you all see that, I hope? So I just gave you a definition that probably needs some definitions inside the definition. Now I'm not going to make you write like all the definition answers or anything like this, but numbers. We're good with numbers, right? Everybody knows what a number is? Yeah? That's what we use in math. Awesome. Numbers that can be written as a comparison of two integers. Does anyone know what is an integer? At your group, try to come up with like group definition of what you think an integer is. I'm going to call on someone. So try to come up with a little... Okay, raise your hand who thinks they have a good definition of what is an integer.
Yeah.
Okay, Delilah, what does your group think an integer is?
Basically like numbers that have like negative numbers.
Okay, very close. Did you get, Eric, did you hear what she said?
Yeah.
Did you hear her? Not quite? Okay, let's say it one more time, but everybody needs to listen.
They're basically like numbers on like
Number line.
the number line, and they're like positive and negative numbers.
Okay. Anyone else think they know what is the definition of an integer? Yes.
Fancy word for numbers.
A fancy word for numbers, okay? It is a fancy word for numbers, but it's not just any kind of number. So integers are numbers that you could count. They're whole numbers, okay? So basically, Delilah was pretty close to right. Any number that could be on a number line is an integer. So are integers, are positive numbers considered integers? Positive numbers that you count? Yes. Are negative numbers considered integers?
Yeah.
Yes. Is a 0 an integer?
No.
Yes, because it's on a number line, okay? Are fractions integers?
No.
No. Okay, so integers are just whole numbers. They can be positive, they can be negative, and it can be 0. Okay, so now that we've got that part down, expressed as a fraction. So basically, rational numbers are anything that you could write as a fraction. So, rational numbers are any numbers that you could write as a fraction. So, is 2 a rational number? Is the number 2 a rational number? Yes. Can you write 2 as a fraction? How would you write 2 as a fraction? 2 over 1. So that's why it is a rational number. So we're going to make this a little bit more clear here. We're going to write it includes, so rational numbers include all integers, fractions, mixed numbers, and percents. So rational numbers includes all integers, which are whole numbers, positive and negative, and 0, fractions, mixed numbers, and percents. Now, the reason that we talk to you about this is because later in this unit, in this chapter, we're going to talk about something called irrational numbers. Irrational numbers are numbers, by definition, mean they're not rational. So there's some things that irrational numbers are basically numbers that never end. So do you guys know what pi is? Have you heard of pi? And not the pie that you eat. Okay? Pi is that funny, like, squiggly line kind of deal thing. Say it again.
3.60.
Very close, okay?
3.14.
Okay, now you think it's 3.14, right? That's what it's rounded to, okay? Pi is actually 3.14 and it keeps going. I think it's like 7, 8, 6, 5, 2, and it keeps going. Okay? I don't have it here yet, but I have a poster coming that shows you how big pi is. No one in the world has ever actually solved what pi is equal to, because it keeps going and going and going. You could like just keep turning in circles and keep going and going and going. It never ends. So that's why it's called irrational, because it never ends. Okay? It means like you could be doing long division for the rest of your life and you would never be done. That is something called an irrational number. We like rational numbers because they have an ending. They mean I can stop doing this math problem. Okay? And I like that for you. Okay? We want you to not do unending math problems. We want there to be an answer and be done. Okay? So, first thing we're going to do today is we are going to, and we did a little bit of this a couple of days ago, is we are going to write each fraction as a decimal. Write each fraction as a decimal. So those are your instructions. And that's what the first part of your homework is going to look like. So for example number 1, I would like you to write the fraction 2/3 as a decimal. Write each fraction as a decimal. So, can anyone tell me, do you remember, how am I going to change this fraction into a decimal? What am I going to start with? Are some of you guys trying to do it already? Asia's already working. Brianna, are you working on it already? Getting some answers, hopefully? Nisa, how do we start?
You would divide the numerator and denominator.
We're going to divide, okay? Now, hardest part to remember here is which one goes on the outside and which one goes on the inside. Does the denominator go on the inside or the outside? The outside, right. So we're going to divide 3 into 2. So does 3 go into 2 evenly to start with? No, so it's 0 times. I want you to put the 0. Then, to be able to divide, we have to put in a what? A decimal point and a 0. Okay, so a decimal, sorry, that was some students that were just waving, saying hi. It's okay, it happens. Okay, so put in a decimal point, put in a 0. Then, how many times does 3 go into 20? 6 times. Okay, do your multiplication. 6 times 3 gives you 18. Okay, subtract. If you need to, by the way, you can always put a subtraction sign here to help you remember. Okay, that'll give you a 2. What do I have to do next? Put another 0. Okay, put another 0 here, bring it down. You have another 0. We're back to where we started. How many times does 3 go into 20? 6. Do your multiplication. 18. Subtract. I'm left with 2 again. It's not done. So I put another 0. Bring it down. 3 goes into 20 6 times. 18. What are we noticing here? It's repeating, okay? Rule is, or my rule is, you have to go to 3 decimal places before you can decide if you can stop, okay? If you're getting the same number 3 times, you can stop. And this is what we call, and you guys already heard it or already said it, this is a repeating decimal. Okay, now, your answer, the short way of writing your answer is to write this as 0.6, and to tell that it's repeating, we put a line on top of what repeats. So you don't have to write 0.666 repeating. I don't want the word repeating. I want you to write it just like this. Also, I do not want you to round, so do not round up. Okay, I want you to leave it just like this as a repeating decimal. This is the answer that I'm looking for. So if I said write each fraction as a decimal, your actual answer here is 0.6 with the line on top, which tells you it's repeating. Anyone have questions on how I did that? No? Pretty good. Okay, let's try another one. Number 2. And I'm only going to do 5 problems for this first set of notes. I would like you to write 3 3/8 as a fraction. Write 3 3/8, as a decimal. Write this fraction as a decimal. So does anyone have any idea where I would start? Help me out, Tiara. Now, a lot of teachers are going to tell you we have to make an improper fraction. I'm going to tell you we don't. It's a little bit too much work, okay? What's the part of this that actually needs to be made into a decimal? Is it the whole number part or the fraction part? The fraction part. I don't want you to worry about the whole number part. We're going to take this whole number and we're just going to put it at the end. We're going to put it in front of the decimal place. So if it's okay with you guys, we're going to skip that step of making an improper fraction. Because it's too much. I don't want to do that work. I don't need to. All I really need to do is make this fraction part into a decimal. So how would I make the fraction part into a decimal? Divide. Which one goes on the outside, the 3 or the 8? And that is the numerator or denominator? Denominator. So put the 8 on the outside, put the 3 on the inside. Now, we know, obviously, that 8 goes into 3 0 times. Duh. Now, let's put in your decimal. So point, add in a 0. 8 goes into 30 how many times? 3 times. 3 times 8 is 24. If you subtract them, 30 minus 24 gives you 6. I'm not done. Bring down another 0. How many times does 8 go into 60?
7 times.
7 times, you think? Okay. Remember, if you did one less, if you did 60, you'd figure out that there was, if you did 6, you'd figure out that there was too much of a remainder, and you'd just start over. Okay, you'd erase and start over. That's why we write in pencil, so we can erase. So 8 times 7 gives you what?
56.
56. Okay, if you subtract, that leaves you with 4. Not quite done. So remember, I want you to take at least 3 decimal places. 8 goes into 40 how many times? 5. 5 times 8 is 40, and I'm left with a 0. Once you have 0 as your remainder, that means you're done. Okay, you are done. Even if you put another 0 here, you would end up with 8 goes into 0 0 times. So once you start getting a 0, you can be done. Okay, this is something called a terminating decimal. Terminating decimal. It's basically a not repeating decimal. Okay, that's what a terminating decimal means. In math vocabulary, it means that it ends with a 0, okay, once you get a 0 at the end of the decimal places. But it basically just means it doesn't repeat. That's all I'm worried about. So a terminating decimal. So if I asked you to write this fraction as a decimal, how would you write it? What would your answer be?
3.375.
We know it's the 0.375, but the trick here is don't forget to bring back your whole number, okay? The 3 from the beginning. So I started with that whole 3. So write yourself a note to bring back whole number. Bring back the whole number. Yes, Nathan?
That's what I said though.
I know. Yeah. I was just waiting for everybody else to see. I heard you. Sorry. Okay, so bring back the whole number. Okay, don't forget that. That's like kind of super important. Okay, anyone have questions on how I did that? Now, we're going to switch gears. We went from fractions to decimals. Now we're going to switch, and I would like you to write each decimal as a fraction. So we're going to switch. We're going to write each decimal as a fraction. So for example number 3, I would like you to write negative 4.16 as a decimal, or excuse me, as a fraction. I have a decimal, I'm going to fractions. Have a decimal, I want to go to fractions. So automatically, what do you know is your whole number? The negative 4. So all I really need to worry about is writing the decimal part as a fraction. So I need to write what's after the decimal as a fraction. How do we do that? Court, do you remember? Oh, yes, yes, go ahead. Anyone remember? How do I start writing this 0.16 as a fraction? Lila?
Put the 4 on its own and then put the 16 over 100.
Okay. How do you know it's 16 over 100? How come it's not 16 over 10? Nathan?
Because of the place it's in.
Because of the place values. Okay, so you're right. It is 16 over 100. I'm going to give you a little trick here. Okay? However many decimal places there are, we always write 1, and then however many decimal places are, that's the number of zeros. So if there was just one decimal place, it would be over what? 10. If there's 2 decimal places, it's over 1 and 2 zeros, so 100. If there was 3 decimal places, it'd be over 1 and 3 zeros, which is 1,000. Okay? So once you get to here, then am I done? No. Why? Blaze, why am I not done? You have to reduce. Okay, so we have to reduce. What do you think 16 over 100 can reduce to be? What goes into both 16 and 100, Tony?
4.
4. Okay, if you didn't see that 4 could go into it, what do you definitely know could go into it? You could always start with 2 if you need to. Okay, and then you can reduce again. But Tony's right, that's something called the LCM, or excuse me, GCM, greatest common multiple, okay? That's the biggest number that goes into both. So yes, if I divide both of these by 4, divide the top and the bottom by 4, what does that leave you with? What's 16 divided by 4? 4 over, what's 100 divided by 4? 25. Am I done? Is my answer 4 over 25? No, why? You have to keep the whole number, so don't forget to bring your whole number. And don't forget that this was negative. Okay, so don't forget to bring it back over here, so your actual answer here is negative 4 and 4/25. Alright, questions on how I did that? Okay, next thing we're going to do for number 4, I would like you to write 0.77 repeating as a decimal. And repeating, so that means I'm going to put the bar over the 7 because it keeps going and going and going. Yes, Chantal.
You said that you can also divide by 2 before.
Uh-huh.
Or the only 2 numbers?
That's it. That's the biggest number that you could divide by. Well, except for 1, but 1 wouldn't do anything for you. Does that make sense? Okay. Yes, Amber. Yes. Just take past right there. Okay, now, this one is a little bit different, okay? Believe it or not, you guys are going to learn this before my Algebra 2 students do, okay? This is something, I'm totally serious, okay? Because we're doing this, I'm sure you guys have heard of this, called Common Core Math, okay? You guys are in like the first wave of it, okay? So you started learning Common Core Math when you were in 7th grade, and now we just keep building. My students that are in Algebra 2 right now never started with Common Core. So they had different math classes. They took pre-algebra when they were in 7th grade. So they have actually not learned this yet. But like my TAs can tell you guys, they learned this in 2nd semester. Writing repeating decimals as fractions, okay? They learned this in the 2nd semester, so the ending of Algebra 2, and you guys are learning it the first week of 8th grade. So that just means that you are that much smarter than they are apparently, okay? You are super smarties. So you were in honors, you were a little more special, okay? They did not get the privilege of learning this early in their educational careers, but you guys do. So the first thing you're gonna do, and I'm gonna give you guys some steps, okay? So first thing you wanna do is you're going to make the expression equal to x. So we're going to start by making this expression equal to x. So we're going to start with x equals, and I'm going to write this, x equals 0.7, and I'm just going to write it with 1 repeat. Okay, so I'm going to write it with the bar above it, so that means it's repeating. Then the next step is you are going to multiply both sides by 1 and the number of zeros that there are repeating, I know this explanation is a little bit long, decimals. So you're going to take this and we're going to multiply both sides by 1 and the number of zeros that there are repeating decimals. So if that sounds a little bit confusing, let's try to clarify it. Okay, so here, how many different repeating decimals are there? How many different numbers are repeating? 1, right? So that means I'm going to multiply by 1 and 1 0. So what am I really multiplying by?
10.
By 10. Okay? So if there was 2 repeating decimals, we would multiply by what? 100, not 20. Sorry, it's like 1 and then 0. So if there's 1 repeating decimals, you multiply by 10. If there's 2 different repeating decimals, you'd multiply by 100. If there was 3 repeating decimals, you'd multiply by what? 1,000, okay? Those are called powers of 10. We have not gotten there yet, but that's what that's called. So here, we're going to multiply both sides. What did we say by? By 10. So multiply both sides by 10. So times 10 and times 10. If you rewrite that, that's going to give you 10x equals, if I multiply by 10, what does that give me here? Multiplying by 10 basically moves the decimal place how many times? 1 time. So it would give you 7.7. And since these keep going, these would also keep going, right? So 7.777, and it will keep going. Did we follow that? Okay. Then the next step is to line up your original problem underneath. Line up the original problem underneath. So that means your original problem, I'm going to put it right underneath. So I'm going to put my x equals 0.777, and it was repeating. I'm going to line it up underneath. Now, this is where the magic happens. Okay, this is where it gets kind of cool. Next thing you want to do is subtract. So we're going to subtract the x and subtract the repeats. On the left side, if you have 10 x's and you subtract 1 x, what do you get?
9x.
There's actually like a 1 in front of this. So the x's stay the same. This is called a common term. Okay, so how many like terms do you have? 10x minus 1x would give you what? 9x equals, what happens here when you subtract? This goes away, this goes away, this goes away. What are you left with? Just a 7. So what I did here by multiplying and subtracting is I got rid of the repeats. Yes, Chantal. Say that again? Can I redo one of what? Yeah, I'm going to do another one. Okay? So here, do you understand how I got 7? So these canceled out, that canceled out, that canceled out. Because we subtracted, this remember was a 0.777 repeating. Now, does anyone know how do I undo, how can I get x by itself? How is the x attached right now? Is it attached by add, subtract, multiply, or divide? By multiply. So remember, there's like an invisible multiply dot here. How do you undo multiplication? Division. So if I divide both sides by 9, these cancel each other out, and you get x equals 7 over 9. That is your answer. So if you plugged it in on a calculator, 7 divided by 9, and I'll show you on my calculator, 7 over 9 is 0.777 repeating. That's how we change them. Okay? You have now learned something before the Algebra 2 students have. And they have trouble with this. So it's going to take a little bit of practice, but we're going to get it. Okay? Let's try one more. Okay, so then what we did was we solved. So, example number 5. This is going to be the last one for this set of notes. Okay, so example number 5. I would like you to write 2.15 repeating as a fraction. Right, 2.15 repeating as a fraction. So let's go through our steps. First thing you do is what?
Make the expression equal x.
Make it equal x. So start by just rewriting this as x equals 2.15. And this would keep repeating, right? If I wanted to keep going. You don't have to write all those repeats, but technically they're there, okay? Or you could just write the bar, because it's a little bit easier to just write the bar. Then, what do you think? I said I'm going to multiply both sides. What do you think I have to multiply by to get rid of 2 repeat decimals? Can I just multiply by 10? No, if I just multiplied by 10, it would move over 1 space, and it would be 21. But you still have that repeat part for the 5. So what do you think I have to multiply by? 100, right. So we're going to multiply both sides by 100. Okay, multiply both sides by 100. So if you multiply by 100, 100x equals, how do I multiply by 100? How many decimal places will it move over? 2, right. So it moves over 1, 2. So that gives you 215. What's left after your decimal point? The 1.5. And is it still repeating?
Yeah.
Still going till we put the bar. What's my next step? Almost there. Multiply to get rid, so I'm going to write down what I did. Multiply to get rid of repeats. Okay, multiply to get rid of the repeats. It can keep going, but I just didn't write it because it keeps going. So I could keep writing them for like ever, but you don't have to, okay? Then here, what do I do next? Line up the original. So I'm going to write, you do not have to write out your steps every time, but I'm going to write it down so that in your notes you like remember what you're doing. So line up the original. So my original was x equals 2.15, and it was repeating. So I'm just going to write the bar. If you'd like to, like Nathan was just asking, you can keep writing another 0.15. You could write for as many as you want to, but I can stop once I put the bar in there. Then what's my next step? Subtract. Okay, so we subtract this. If you subtract, what's 100x minus 1x? 99x's. Equals, what happens when you do this subtraction? Remember when we do subtraction, you always move from the right to the left. So what happens with all these repeats? They cancel each other out, right? They go away. So is there anything left after the decimal point? No, which is what we want. Remember, we're trying to get rid of the decimal places. What's 215 minus 2? 213. And then your last step here is to solve. So how could I solve? Solve means get x by itself. Divide both sides by what? 99. By 99. Now, technically, you do have to rewrite this as a mixed number. So, how can I rewrite this as a mixed number? Anyone know? We're going to have to divide, okay? So we know that x equals 213 over 99. How do I write this as a mixed number? We're going to divide. The number on the bottom always goes on the outside. Now, I don't know about you, but I am not very good at my 99 math facts, okay? I do not know very many multiples of 99. But how do I know how many times 99 is going to go into 213? Does anyone see kind of a shortcut? Kylie, do you see a shortcut? Do you know how many times 2 is going to go into 99 is going to go into 213? Twice. Why do you think twice? Because you just did it in your head? What other big hint do I have here that it would go in 2 times? Come on, I know you see it. Oh, I've talked to all of you guys today. Drew, where do you see it? Oh, okay, it's basically 100. Okay, you're getting there. Maddie. Okay, you did 100, so you know it was 2 times. Okay, you guys are almost there. Holly, what do you think? We started with 2 at the beginning. Yes. So whatever you started with at the beginning, you know that's your whole number. We just need to find the remainder. Okay? So we started with 2 at the beginning. We know that. Okay? You already knew the whole number. So I could draw this little thing here. You already knew it. So we know it's going to go in 2 times. Now, yes, you have to do 2 times 99. So if you need to, on the side of your paper, let's multiply 2 times 99. Okay? 2 times 9 gives you 18. Carry your 1. 2 times 9 is 18 plus 1 gives you 19. So do we agree that 99 times 2 is 198? Yes. So 198. Okay, do your borrow and carry stuff. Tell me, what is 213 minus 198? 15. Now, I do not want to get a decimal. Because if I added in a 0 and got a decimal, guess what? I'd be right where I started. I already did that part, okay? I don't want you to get more decimals. So, how can I write this as a fraction? Delilah, do you know?
15 over 100.
Very close, not quite. 15 over what? Rihanna? 99, right. So this is your remainder over what you started with. Then, how can I reduce this? Because remember, I want nice, pretty, reduced fractions. Tony?
Divide it by 3.
Divide it by 3, right. So we want to divide by whatever's going to go in there evenly. Okay? So if you think in your head, what are the different things that could go into 15? 5, or what else? 3, or a 1, or a 15, okay? But really, you want to think about, okay, 5 and 15, well, 5 and 3, sorry. Does 5 go into 99? No, because you know if something's going to be divisible by 5, it has to end in what numbers? 0 or 5. So 3. Does 3 go into 99?
Yeah.
Yeah. Okay. So we can divide both by 3, so, or reduce both of them by 3. 15 divided by 3 gives you what? 5 over
33.
33. Now, don't forget to bring back your whole number. Okay, so don't forget that that whole number has to go there. That is your answer. Now, I know that was a long problem, but you don't have that many that are like that, I promise. Okay, does anyone have any questions on how I did that?
I'm still trying.
You're still kind of confused. That's okay. Okay,